Hello, everyone. Have a good day. So, myself, uh, Dr. Nada Ravishankar from SRM Institute of Science and Technology. So, we are gonna discuss about the course Computer Networking. So, throughout this course, we are going to discuss the basics of computer networks, history, and the topologies, and the TCP/IP protocol model, OSI layer protocol suite, switching methods, and the different types of media, right, and the functionalities of each and every layers of TCP/IP protocol suite. Okay, so if you have any questions related to computer networks, right, you can comment here or you can contact me for further discussion, right? So let's get started. So the first module is the introduction to the computer networks. So computer networks, uh, in this module, we are going to discuss about the introduction history and the different types of topologies, network types, switching techniques, layered architecture, uh, physical layer overview, guided media and unguided media, right? So introduction, as you can see, computer networks, right? Computer networks is the interconnection of two or more devices connected to each other through a wired or wireless medium in order to share the resources and in order to enable the communication between them, right? So basically networking means connecting, right? Connecting together. So for example, uh, uh, for us humans, we are connecting to another people or another group of people through LinkedIn, YouTube, Facebook, etc. There are lot of social media that are available where people can connect, right, in order to share their knowledge or in order to communicate between them. Similarly, in order to enable the communication between two computers, we are creating computer networks, right? Computer networks is basically interconnection of two or more computers, right, in order to share the resources and communication, right? So computer network is a very good platform when computers communicate and share the resources, because it will create a lot of useful things like the latest technologies like cryptography, then blockchain network, right? All are based on the concept of computer networks, right? So computers can do a lot of things, right? Individually or group, right? So computers on a network can act as either a client or server, right? So client or server architecture, most of you heard about client server architecture, right? So a device which requests for a particular service will be called as a client machine, right? The machine who provides the service to a particular machine will be called as a server machine, right? So computers on network will also act as a client or server, right? So client or server, you can easily define that. So before getting to the concept of data computer networks, first we should know what is meant by data. Data means the information presented in whatever the form mutually agreed by both the parties. So here the parties means both the sender as well as the receiver. See, for example, as people we can uh, talk only in the languages that we know, right? So I can understand only Tamil or English means the receiver or the sender can only speak in Tamil or English, right? If we speak, if the person speaks in any other language, I cannot understand. So there is no use of communicating the knowledge or communicating the data in a different form that the receiver cannot understand, right? Similarly, the data here means the information presented in the a required form or acceptable form mutually agreed by both the parties or both the devices, right? Sender and receiver. So data communication means, so now we are clear about what is meant by data. Data communication means the exchange of data between two devices. We have some form of a transmission medium, right? The medium can be either wired or wireless, right? So data communication means we are exchanging the data between two computers, right? So one will act as a sender, another one will act as a receiver. So next one is, what are all the components or basic building blocks of data communication? So in order to establish a data communication between two or more computers, we need some basic components, right? Basic components. Say for example, if you are listening to a movie or another person who is talking, right? We need basically three components, right? Three components are required for any type of communication system. One is a sender, another one is a receiver, the third one is medium, right? Medium which will connect the sender and receiver, right? So if a person is speaking and another person is listening to the voice, speech means the person who is speaking is called as a sender, right? The person who is listening is called as the receiver, right? Here the medium is air. So if you are talking on over a phone, then the medium is the wireless one, air, right? Your voice generated from the your speech generated from the vocal is called as your sender, right? The speech will be recognized by the person at the other end using his ears. So ears will be known as the receivers, right? Similarly, for data communications to happen, we need some basic components, right? Basic components. So there are 5 basic components required for any type of data communication. They are protocol, sender, message, receiver, and the transmission medium. So as you can see here, sender and receiver are the devices, right? The transmission medium are the wired medium or wireless medium which will connect both the sender and receiver. In addition to the common 3 components, that is sender, receiver and medium, we need 2 more components for data communication. One is protocol, another one is the messages, right? So here the messages will be represented in a data format. Data format means basically computers can understand only binaries, zeros and ones. So basically all of your user messages will be represented using zeros and ones. And the next one is protocol. We have different set of layers, right? Different set of layers. So each layer will have its own responsibility and processing ability. So the message will be processed in each and every layer. At last, at the physical layer, the message will be converted either to electrical signal or radio magnetic waves, right, or a light signal in order to transfer from sender to receiver. Okay, so these are all the basic components of data communication. So this is all about the basic components of data communication. So why do we need computer networks, right? So as we discussed, the basic functionality, basic objective of any computer network is to share the resources, right? Share the resources. For example, if you want to do construct a small network for your organization, right? With about 10 systems, right? 10 systems. So later you want to connect all of your systems to a printer, right? Printer. So if you want to purchase 10 printers for all the 10 systems individually, the cost will be expensive. So in order to reduce the cost, you can have a network, right? Network, so that you can share the hardware resource like a printer or software resources like drives, right, memories, etc., so that it will reduce the time and expense, right? So the basic objective of any network is to share the resources and to enhance the communication, right? It will also facilitate centralized management, right? Centralized management or administrator to take care of the entire networks, right? In order to increase the efficiency of the network systems as well as to reduce the cost, maintenance cost. Okay. So the data flow based on the data movement, uh, the data flow is either categorized as simplex mode, half duplex mode, or full duplex mode. So see, you can see here, if your data is moving in only one direction, then it is categorized as simplex mode of transmission, right? Simplex mode of transmission. So where data will move only in one direction, right? Whereas in half duplex, data will move in both the directions, but not at the same time. Only one can speak at a time. The best example is walkie-talkies, right? Walkie-talkie, if you look at the walkie-talkies, only one person can talk at a time, right? So once the person completes his speech, right, another person will take over the control using the knobs or buttons, right? So half duplex means communication is possible in both the directions, but not at the same time. Whereas full duplex, both the directions communications are possible without any restrictions, or in other words, a bidirectional communication at all the times, right? So these are all the different types of data flow, right? Data flow. So network criteria. So for any network, right? For any type of network, we have certain characteristics or criteria to assess the performance or reliability or security of such networks, right? So network has to meet certain number of criteria. The most important of these criteria are the performance, reliability, and security. Performance includes everything: the rate of transmission, speed, processing ability, everything. Reliability is basically the probability, how much it is reliable even in the case of traffic, right? Security is another concern, how much securely it can transfer the data from one end to another end. So these are all some important network criteria while we design a network, right? Then the classification of networks, right? Classification of networks is basically depends on the geographical location or depends on the physical arrangement, right? Physical arrangement. So geographical location, based on the geographical location, we have a different set of network types like local area network, metropolitan area network, wide area network, pan area, personal area network, right? Based on physical arrangements, we have star topology, bus topology, ring topology, and mesh topology. So before discussing to the types of networks, right? So we should know what is meant by point-to-point connection and multi-point connection, right? So point-to-point connection, in point-to-point connection, we have a dedicated link is established between the sender and receiver. See, if you look at the diagram here, a dedicated link is established between the sender and receiver, either permanently or temporarily. A dedicated link or permanent link is established between the sender and receiver. So in such cases, there is no need of any traffic control, any monitoring, any administration, because we have a dedicated link, right? So anytime you can transfer the data without any traffic, right, issues or administration issues or any monitoring issues. Whereas in multi-point connection, you have a common channel, right? You have a common channel through which a number of systems may be connected, right? Number of systems may be connected to access the channel, right? So if you want to transfer a data through a common channel, then there may be a possibility of traffic, right? Then any other distractions, right? And you need to take care of the controlling of the channel activities, right? Monitoring, etc., right? So multi-point environment requires any central administrator or central management to take care of the channel access, right? Channel access. So LAN will discuss about the types of geography based networks, right? Computer networks. So local area network is the smallest geographical area, covers only the smallest geographical area, uh, basically some few 100 meters, right? Few 100 meters. So LAN will be used to establish within a small room or small building, right? If you want to establish a computer network within your room, right, or within your building, or for your small organization, you can make use of local area networks, right? Uh, it is inexpensive to install, and maintenance is also easy, right? High speed performance is also possible by using local area network, right? And for sharing the resources, local area networks are very much useful, right? Very much useful, and security and reliability can also be easily achieved in local area networks, right? So local area networks, you can access any hardware or software resources through any of the topologies, right? So these are the characteristics of LAN. LANs are private networks. Most of the times LANs are private networks, right? So you don't need to get any license from the regulatory controls. So LANs operates at high speed, right, when compared to WAN or MAN, right? So that geographical area is very much less compared to other networks. So it is very easy to take care of the controlling methods, monitoring, etc., right? The next one is the metropolitan area network, right? Metropolitan area network can be combined by integrating multiple local area networks, right? Multiple area networks. For example, uh, within the Chennai city, uh, we will have a number of banking sites or a number of branches of a particular organization. So if you want to connect all of these branches, right, then you can combine all these local area networks together to create a metropolitan area network, right? So the region of or the geographical area for man is basically few kilometers, right? Few kilometers. The maximum will be 30 kilometers, right? Maximum range for metropolitan area network is 30 kilometers. So the government agencies and banking sites will make use of MAN to connect their branch portals, right? Branch portals together to maintain their operations, right? And it has higher range than LAN, but the control and the monitoring activities will become complex, right? So the general characteristics, it may cover up to 50 kilometers, but the range will be approximately 30 kilometers. The communication medium used for MAN will be either optical fiber cables or high performance, high speed cables, right? So data rates more data rates will be required for MAN based applications, right? MAN based applications. So it can be used in banking sites, railway reservations, airline reservations, right? The next one is wide area network, right? Wide area network, so it can be either private or public, right? So private means it belongs to a organization or industry, whatever it is, right? Or it can be public leased network, right? So you can integrate multiple LANs and MANs together to form a wide area network. So the best examples are mobile, a broadband network, private networks, satellite networks, all are examples for a wide area network, right? Wide area network. So it will cover the entire countries around the world, right? It can also operate on low data rates, right? Low data rates. So it covers large distances, states, countries, continents, as I said, right? So most of the networks, wide area networks are implemented using satellites, public telephone networks, right? Which are connected through multiple routers, the millions of routers, right? Both wired and wireless medium will also be implemented for WAN, right? So there are different types of WAN, point-to-point WAN and switched WAN. Point-to-point WAN, you have a dedicated link from one country to another country to establish point to point WAN, whereas switched WAN, you'll have intermediate devices or routers will be there to forward your packets from one end to another end. So the last one is the personal area networks. Personal area networks are nothing but your Bluetooth devices. So the range is very minimal, maximum of 10 meters, right? 10 meters or 30 feet, right? Most of your Bluetooth devices, right? Bluetooth devices are operating under this range, right? Most of your headphones, mouse, wireless keyboards, wireless printers, right? So you can connect all these devices within 10 meters or 30 feet, right? So next one is the classification of networks by physical topology, right? Physical topology or physical arrangements. So how you are arranging the computers to establish a network, right? So if you look at the diagram, see the first one is the mesh topology. So the mesh topology, for example, I have taken 5 systems. So mesh topology is nothing but all the systems are connected directly, right? All the systems are connected with each other, right? See, I have 5 systems here, right? All the 5 systems are connected to the remaining 4 systems, right? For example, if you take the first one, right, it is directly connected to all the 4 systems in the network. So this way you can create connections so that it will create a mesh topology. So mesh topology, it has a dedicated point-to-point link to every other device which is there in the network, right? Which is there in the network. So in mesh topology, the number of connections required for network connections is generally n into n minus 1 by 2, right? N into n minus 1 by 2. So n is the number of nodes or devices in the network, right? Number of nodes or devices in the network. In this case, we have 5 systems. So n is equal to 5. So if you put the value for n equal to 5, 5 into 5 minus 1. So 5 into 4, 20 divided by 2, which is equal to 10. So for 5 systems, it requires 10 links. So if you have large number of systems, the number of connections required for this topology is very huge, right? That is practically difficult to manage and expensive. So that's the only drawback of this topology, but it has a dedicated link that guarantees the delivery of the packets from one end to another end, right? So the next one is that star topology. Star topology, all the devices are connected through a central hub, right? Central hub or central controller. See, all the 4 devices are connected through a central switch or central router, right? So which is called as a central controller. So all the communications are possible only through this central controller. So if you want to transfer a packet from one PC to another PC, so it is possible only through the central controller. All the packet has to pass through the central controller or hub, right? So if the central controller goes down, the entire network will fall down, right? So this is the disadvantage of star topology. The next one is the bus topology. So bus topology, if you want to create a computer network, you can lay a main cable or backbone cable in such a way that you can connect as many systems as you want, right, through a drop line cables or Ethernet cables, in other words, right? So you can, if you want to develop a computer network within a room or within a building, first you have to lay a main cable. So the dotted solid line will represent the main cable, right? So after that, you can connect a number of systems, right? Number of systems through drop line cable or Ethernet cable. So most of the traditional Ethernets are implemented using the bus topology, but they are not at all used now, right? The next one is tree topology. Tree topology will form a hierarchical structure like parent tree arrangements, right? Uh, so basically the structure will resemble a tree. That's why it is called as tree topology. So there is one central node, and each node is connected through the central node through a single path. So if you want to communicate to the particular node, you have to go through the central hub and then to the parent node and then through the child node. So this is how the data will move from one end to another end, right? So the disadvantage is that if the primary node goes down, then the entire system can be crippled because all the nodes are connected to the primary hub, right? So last one is the ring topology. Ring topology, it will resemble a ring structure, right? Ring shape or ring structure. So so the main thing is each system has only two connections, right? See, if you look at any device, it has only two connections, one on the right hand side and one on the left hand side, right? So that it will form a ring shape or ring structure, right? So it has only it has only two connections at any point of time, right? So signal is passed in one direction from one device to another device until it reaches the destination device, right? So data will move in only one directions, right? So to add or delete a device in the ring structure, you need only two connections, right? Two connections. So the disadvantage is if any one of the device connection goes down, again the ring will break down, so the entire structure will collapse, right? Then next one is the hybrid topology. If you combine any of the topologies, right, then it will form a hybrid topology. For example, if you combine bus topology and ring topology or star topology, whatever it is, right, then it will create a hybrid topology. So hybrid topology is basically a complex one, but it offers various advantages such as flexibility and fault tolerance capability, but it's a complex one to create. So it is not at all used in the real-time market, right? So the next one is switching techniques. Switching techniques. So switching means, passing data from one end to another end, right? We have basically three types of switching: circuit switch networks, packet switch networks, message switch networks, right? So switching means, right, it establishes a connection between two devices together, right? Two devices together. A switch, if you turn on a switch, right, the data will be forwarded from one network to another network when required, similar to our switches in the home, right? If you turn on the switch, the fan will turn on similarly, or the light will turn on, right? If you turn off it, the current flow will stop, so that the light or fan will automatically cut off, right? So the two most common types of switching techniques are circuit switched network and packet switched network, right? So circuit switching and packet switching is basically nothing but circuit switching will have a dedicated connection, right? Dedicated connection. See, most of the traditional, right, telephone networks, right, are best examples for circuit switching. So circuit switching, you have a dedicated line between the sender and receiver, right? Sender and receiver. So the thick line connecting the two switches is a high capacity line, right? High capacity line that handle the voice communication from one end to another end. So fixed data, we cannot change the data capacity of these lines, right? So but it is able to transfer your data completely from one end to another end, right? So circuit switching will require three phases. first one is the connection setup, right? Transmission phase and termination phase, right? First, before transmitting the data, you have to establish the connection, right? Establish the connection, then the actual transmitter takes place. After completing the transmission, you have to terminate the connection, right? So these three are the important requirements for circuit switch network, right? So circuit switch networks are not efficient because you need a dedicated line and it requires some time for establishing the connection, right? For establishing the connection. So it will create unnecessary delays in the data transfer, and it will create a burden for the data transfer, because in order to create the connection, you need to send some data, additional data, as well as to terminate the connection, you have to send some data, right? So it is not efficient as compared to packet switch network, right? So delay is also high compared to packet switch network, right? So the message switching and other things we'll discuss in the next course, right? So if you have any questions, you can contact me. Thank you.